Here are the examples for day 2 of section 4.1. Here we have a polynomial. P of x equals negative 2x to the third minus x squared plus x. Basically what you need to see here is that there's an x in each of these three terms. So we're going to factor out x. We get x, and then in parentheses, negative 2x squared minus x plus 1. Inside we have a quadratic. We can do diamond method, or we can just use quad 3 on our calculators, because that's not the whole point of this lesson, is learning how to or remembering how to do quadratics. It's being able to graph polynomials. So if you use quad 3, you will see that you get negative 2x plus 1 and x plus 1. So now we've got our three factors for our polynomial. And already up here, I could have done this to start. We know that our leading coefficient is negative 2, meaning it's negative, okay? And our degree is 3. So that's an up and down type thing. And since it's negative, it's going down. It's going to be going down from left to right. So it's going down like this. And so on the left, it's going obviously up, and going to the right, it's going down. So that's our end behavior. Okay. And here we've got our zeros. We have x equals 0. Negative 2x plus 1 equals 0. We're going to subtract 1. Get negative 2x equals negative 1. We'll divide by negative 2 and get x equals 1/2. And then x plus 1 equals 0. We will get x equals negative 1. We also need to find our y-intercept. And it, again, is when x equals 0. So if we plug in 0 to our original polynomial, we get 0. So our y-intercept is 0. Okay? Now we want to put all of this onto a graph. Okay, so we've got our zeros at 0. Actually, I'm going to give myself some space here because my zeros are really close together. And we have 0, which happens to be a 0, and our y-intercept. We have x equals 1/2, which is right there, and x equals negative 1. And our end behavior is going up to the left and down to the right. Each of our factors, our zeros, all had a exponent of 1. So the behavior at the 0 is linear. And so we're going, since we're above here on the left side of the 0, the point, we're on the left above it, we're going down to the right. Now since we're down below this point, we've got to be able to come up through. And then we're above this other point, we're going to be going down through. So those are lines, linear. And if I connect these with the red, just to show how these are going to connect, and to make this smooth and continuous, we're going to just curve around here. We're going to curve here and then go down. And so that graph is going to go up and down like that. And our graphs, our points are close enough together that I don't need to really test in here unless you really feel the need um, to make sure that you're giving an accurate graph. Now another example is having p of x equals x to the third plus 3x squared minus 4x minus 12. Here we see that we have four terms. Anytime we have four terms, we do not have a greatest common factor, so we're just going to draw a line down the middle, and we have to factor out a greatest common factor from both sides of this line. Here we have x cubed, we have x squared. I'm going to factor out x squared. I'm left with x plus 3. Over here, because this first number is negative, I'm going to factor out a negative, and 4 goes into 12, so negative 4. When I factor that out, I get x, and negative 12 divided by negative 4 is positive 3. So now you can see I've got x squared minus 4. That's one factor. And I also have x plus 3. And I don't count that twice. I just have it there in common. It is a common factor from both sides. Now, x squared minus 4 is an a squared minus b squared. I need to be able to recognize that. So I'm going to have two more factors where I have a plus b and a minus b. So that's x plus 2 and x minus 2 because square root of 4. B squared is 4, so square root of that, you get 2. And then I have x plus 3. So I have three zeros. X plus 2 equals 0. I get x equals negative 2. For x minus 2 equals 0, I get x equals 2. And for x plus 3 equals 0, I get x equals negative 3. So three zeros, kind of spread apart. Oh, go back. I need my leading coefficient is a positive 1. My degree is 3. So positive goes up from left to right. So it's going to look like that for a degree of 3. My y-intercept is when x equals 0. So if I plug in 0, I will get negative 12 because 0, 0, 0 minus 12. So y equals negative 12. All right, so here, oh my, let me start this over and just use a line. And we'll make it blue. All right, there we go. And we're back. So when we plot our points here, 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. So our y-intercept is negative 12. We have our x-intercepts negative 2, positive 2, and negative 3. Okay, well, since I have 1 and negative 1 there and my y-intercept here in the middle, I'm going to go ahead and test those. So if I plug in negative 1 I would get -1. Let me go up to the beginning. So -1 to the third plus 3 times -1 squared minus 4 times -1 minus 12. When I work that out, I get -6. And when I plug in x equals +1, I get 1 cubed plus 3 times 1 squared minus 4 times 1 minus 12. And with that, I will get -12. Quite a difference. So 1, 2, 3, 4, 5, 6. So -1, 6 is right there. For +1, we are at -12. So we're dead even with our y-intercept. Now our end behavior was going from lower left, okay, so lower left down here and up to the right. Okay. All right. Each of our factors each had an exponent of 1, so they are all linear. So they're all linear. So that means I'm going straight through, straight through, straight through. So because I'm down on the left, I'm going up to the right, down to the right, up to the right. So now I need to pay attention to that as I draw the rest of my graph, smooth and continuous. And here, I've got to go through that point. I've got to go through my y-intercept and then back through that point. So it's just a, and so, oops, and whatever. So it's not going to be perfect up there, but I could make it look a little bit better and just kind of go up and draw my arrow. Okay, so there's my graph, and it's fairly accurate because of graphing my other points here between my zeros. And that's it for day 2 examples.